Planet Mars? No, a mining area in the south of Spain, where the iron deposits on the rocks give earth and water the same red color, hence its name, Rio Tinto, the colored river. Once a fertile mining area, it's now become an ideal ground for researching Martian geology, at once so similar and so different from the Earth. Millions of years ago, Mars and the Earth probably shared the same primitive environments. So if life existed on Earth, one can admit the hypothesis that it could also have developed on Mars. What would be most likely is to find microscopic forms of life, microorganisms rather similar to those we can find on Earth. The hostile Martians imagined by H.G. Wells will remain a product of his fertile imagination. But the big question remains unanswered. Has life ever evolved on Mars?
Europe has declared, in a way, its clear priorities for exploration of Mars, and they relate directly to the finding of evidence of past life, potential for future life, and indeed, perhaps in an ideal discovery, the one we really want to make, evidence of present life.
Since the first telescope observations of Mars in the early 1600s, scientists have suspected that Mars is more Earth-like than any other planet. To confirm this, the European Space Agency launched in 2003 the Mars Express mission, and the first real proof arrived. But the main quest remains to find traces of water in any form.
You look at the surface of Mars, it really looks as if there's been liquid. In many places on the surface, you see evidence of things that look like rivers, of structures that you would see in a dried up stream bed, but frustratingly, you don't see the water. Of course, and we know below the surface, there are layers of ice. This is, again, one of the great discoveries of the radar on Mars Express. We Europeans have been rather obsessed with getting below the surface, and even Mars Express got below the surface by sending signals down below the surface and seeing reflections from ice. I think a challenge for us on a planet like ours that absolutely exists, where life exists only because of the water, is to understand where the water went.
If we can determine why Martian water disappeared in the past, we may learn more about whether a similar fate one day awaits the oceans of Earth. But Mars Express made other important discoveries. Methane, a gas associated with geological or biological activity on Earth. Impressive as they may be, Mount Olympus and the rest of the Martian volcanoes have long been inactive. So if it isn't geology, what is producing the methane on Mars?
If there is organic activity on Mars, it almost certainly has to be below the surface. How far below the surface? Well, there's a limit to how far we can dig, but we can go down 1 or 2 meters if we put the effort in to develop the capability to do that.
This is the philosophy behind ExoMars, a joint ESA-NASA future mission which envisages the launch of a Mars orbiter and a rover to provide more answers on what lies above, but especially beneath, the red planet's surface. Apart from being a prime candidate for future manned exploration, digging into the past, present, and future of Mars can also help us understand the evolution of life on Earth and identify potential new homes for mankind in the distant future.